All right, so today we're talking about application problems for our next algebraic manipulation test. All right, so applications, there's several kinds. One is this kind, and I've showed you this formula before. I would like to take just a second and see how many of you remember it without me saying it to you. Would you please write it down from memory? Don't copy it from the last night's notes. It starts with amount 1. Write it down, because you'll use it on a problem in just a second. It'll be handy to have on your page. All right, pretty much everybody knows the amount 1, percent 1. Amount 2, percent 2. That only makes sense. If you're going to use amount 1, you probably use amount 2. But what do you do after the equal sign? What's this part of the formula? Amount 1 plus amount 2, and then what? Total percent. How many of you would have been solid on that? You could have done it already. Awesome. So then you don't have to worry about memorizing that. You've already memorized it. So now it's using it. So what if I say, don't write these down, just listen for a second. What if I say I'm adding pure acid? What percent is that? 100%. What if I said I was adding some unknown amount of 5% acid? That's really weak acid. Like pop. Pop is an acid. Did you know that? It is. If you leave pop on your teeth long enough, they will dissolve away. That's why dentists don't like pop, because even just drinking it, being exposed a little bit, and then your saliva washes it away, it slowly wears your teeth down. If you were to take your teeth out, put them in a bowl, keep pouring pop on them, they would dissolve away to nothing. They would disappear, because pop is an acid. All right, anyway, so if we were to take some amount of 5% acid, that's like N, and I go 0.05 for 5%. You know what I'm talking about? All right, then if I wanted to add stronger acid to it, like let's say 80% acid, then that would be, this one would be 0.8. And I add, let's say, 100 milliliters of that. Then I could figure out what percent it would be. And I would go N plus, what's the other number? 100. And in fact, if you told me, if you leave this as a question mark, I don't know how much I had that was 5% acid, then you couldn't finish the problem because you'd have two variables. All right, so let's say what we want for a total percent. Instead of 5% and 80%, something in between, let's say we want 75% acid. That's a typical way to set it up. Then you just got to multiply it out and you got to solve for the variable. All right, so I want you to use this one right here, and I want you to figure out the answer, start to finish. Right now, this is a typical test question. See if you can handle it. All right, so if you're having trouble setting it up, I'll start that. I don't know how much 70% plus 75 milliliters of 25%. Amount 1 and amount 2, 1 or 75, 12%, 30%. Okay, so next I get these numbers, I put them together, and I got to get rid of the ends on both sides problem. Get rid of the smaller one always, because then your answer will come out to be a positive N if you get rid of the smaller one. And then I need to take 22.5, clear, 22.5 minus 18.75, 3.75, 0.4 N is 3.75. And what is this, like 9 point something or something? What'd you get? 9.375? Awesome. Now let's make sure it makes sense in context of the question. Because if this was like how many cheeseburgers the little girl ate, it'd be like, no, that doesn't make sense. 9.75. So do I need, okay, that's probably not buckets of acid. It's probably 9.75 milliliters, because the other one was in milliliters. Or 9.8. What was it? Like 9.375. So let's say 9.4. And does it make sense that I wouldn't need to add much acid? Well, it was 70% acid. No, wait. it was 25% acid solution, and they're adding strong acid to it, and it only needs to go up to 30% acid. Do you get how it doesn't going to take too much? That makes sense to me. So 9.4 seems reasonable. So always check your answer for being reasonable. And it's 9.4 milliliters. All right. So that's a kind of problem I hope is a shoe-in for you on the test. If you see a mixture problem, that should be like a awesome, I'm glad to see that because I'll get that right kind of problem. All right. There's another question I don't have here, but I'm going to include it because it's important. And it's about maximizing or minimizing. When you graph something and you want the minimum, you want the low spot, right? When you graph something and you want to maximize it, you want the high spot. When you picture, let's say that you are a farmer and you are going to start raising buffalo. I just read a story, or heard a story read to me over the radio that was about buffalo and how the price on buffalo meat has gone up dramatically. It's like really high right now. There's only about 400,000 buffalo that are raised for meat, and there are, because they're just like cattle, just like cows. And cows, though, there's like 15 million cows that are raised, or beef cattle are raised to eat the beef. So compare that between the two, 15 million compared to 400,000. It's a lot more beef out there. So anyway, but why are the buffaloes kind of popular right now? Because their meat is pretty healthy. Picture I think people also can just imagine the scene. They got these buffalo that are out wandering in the hills. They're eating grass. They're not eating corn fed to them by the farmers. And so people think, oh, it's pretty healthy because these buffalo are just eating grass. And so that's all natural, and they're supposed to be pretty low in fat. And so anyway, buffalo meat's been pretty popular. So you decide you're going to raise buffalo because you heard that you could make some serious cash, because right now the prices are pretty high. So what do you need? Well, you need to be able to keep your buffalo kind of in, and buffalo can jump fairly high. Buffalo can jump over a 6-foot fence. Okay, so just picture that. They could jump over you. Standing next to you, they could just jump up and over you. And I would hate to have them actually do that because something might hit me on the head on the way down. But anyway, so if you have to have a 6-foot high fence, then you're going to have a fair amount of expense to try to fence in stuff. Because if they can go over a 6-foot fence, you probably have to have at least a 7-foot fence. So it's going to be kind of expensive to fence in your land. So you want to use the minimum amount of fence, right? Okay, so let's say that we have our land. It's going to be on some kind of a rectangle. You don't usually do big circles to keep in your buffalo. I don't know why, but they usually have rectangles for fences. And I'm going to label it with length and width to start with. Would you please draw this on your paper and label it with width and length? Now, let's say that I find out for the amount of buffalo that I want to run that I am going to need 4,500 square feet. Okay, because there's probably somebody somewhere who knows how many square feet you need per buffalo for them to be able to, like, forage, get their food. All right, so I'm going to need 4,500 square feet. That's an area, right? But yet I have a perimeter question, which is the fencing needs to be the smallest possible. So I need two formulas. I need the area formula. Write that down. I need the perimeter formula. Hopefully you know it by heart because we used it earlier this year. Perimeter equals. Fill it in if you know it. And if you don't know it, copy it for me in a second. 2 lengths plus 2 widths. All right, so there's my general formulas. Now, which of the numbers do I actually know right now? A. I know A is 4,500, so I can put 4,500 here equals length times width. That means I can rewrite this length and width in terms of just one variable, and the book is going to consistently ask you to use x, and I'm going to strongly recommend you use that be the width. So my W is now going to be x's. So I'm going to change my W's to x's. Wherever I see a W, W is now an x. So what I just did there. Okay. Now, my length. I really should use something in terms of x. So I just have to solve my length. Length right here. That'll tell me what length is in terms of x. can you divide by x on both sides in your head and say length would be 4,500 over x? You get that? From this I got length is 4,500 over x. So my length, 4,500 over x. Now just think for a second. If the total area was supposed to be 4,500, that means this times this is supposed to equal 4,500. Do you see that it would be? If I times those together, do you get how that would be 4,500? All right. So now, I've got my picture. My picture is labeled pretty well. It's got like just one variable on it. I got formulas. I've got everything I need to finish the problem. So I've already kind of used my area formula. And besides, I don't want to maximize my area. I want to minimize my perimeter. That means I want to have the least amount of fence possible, because that's expensive. What if it's like, you know, 50 bucks a foot to put up this fence? And I'm going to be like, if I can find a way to make it cheaper by 3 feet, that's going to save me 150 bucks. All right, so I want to minimize this. Well, now I just stick in what I know. I don't know my perimeter. But I do know my length. 2 times the 4,500 over x. And 2 times the x is 2x. Do I now have my perimeter in terms of x? So now, what's the only other thing? If I was going to graph this, do you ever graph p on your calculator? No, you usually graph what? Y. So you say y equals, and now that looks like something I could graph. Once I got done graphing it, you are going to probably be confused when you see the graph, because it doesn't make sense. But before we do that, we should do one more thing to simplify. Do you get that when I multiply this by 2, that the 2 would be times the top, and it would be 9,000 over x plus 2x? And one more thing, if you put this on the calculator, you need to have parentheses around this, or it will think you meant to just take x divided by the 2x. You don't want that. So put parentheses. If you type it in exactly this way on your calculator and then graph it, I bet you anything you'll be a little confused. To try it. I will try it too. So there you got it, 9,000 over x in parentheses plus 2x. And then if I go to, if you just do a zoom 6, like a standard graph of this thing, you won't even see it. Why? Well, the numbers are so big. On this graph, I'm only going out to 10 and negative 10. That's not going to be there. The numbers are big. So if I do zoom 0, do you get how on the left-hand side of the graph, this part that's less than 0 doesn't make any sense? Because I can't have a negative length for my sides. You get that? All right. So now looking at the other side of the graph then, if I just blow up that side of the graph here, it kind of looked like this. It looks like there's an asymptote like or something, but I can't see where the low spot is in this because it just keeps going down, down, down. Just look at it again and we'll convince yourself that, do you see that it doesn't look, there's like a low spot there? That really confused me in one of my first hours. And then I went in, I was like, I know there's an answer to this, I can't remember what to do. I asked one of my colleagues and they were like, oh, you just need to have a better window. All right, so let's go to the window. Hit window. Now let's think it through for a second. What are the x's? They're the lengths of the side. Would it make sense to have any negative lengths of sides? No. So let's go to x min is 0. And the maximum length of my side, well, this is holding in like a bunch of buffalo, so it's going to be a lot of feet, isn't it? So let's go x max of, let's say, 1,000? I don't know. Let's try it and see if that makes sense. I'm not sure. I think you could tell that. And so it's okay. You just try it. Get a number that seems somewhat reasonable. The scale, you always leave at 1. Y minimum. The y is the perimeter. Does it make any sense to have a negative perimeter? No. So we should have 0 for that. 0 is the smallest perimeter. And to the max, I don't know. What's the biggest perimeter? Well, we know that we want to be the least that way it can possibly be. But again, we got to hold in buffalo here. I don't know how. Maybe like 10,000 or something. All right. And then, almost like magic, when you hit the graph, you can see there is a low spot, isn't there? It looks totally different than the other graph. It's because we're zoomed way out, whereas before we were zoomed way in. Like, if you look at this, the graph goes like this. And so if you only zoom in on this part of it right here, you see how it only looks like it's going down? And if you zoom far enough out, you can see that the graph actually does have a minimum or a low spot in it. So I'm going to look at mine again and say, how could I make this even better? Well, I really don't need to be so far over on the x's, do I? Like, most of the action is happening, you know, closer in. I don't need to be way over there. So I'm going to go back to my window, play with my x max, and 1,000 was like way too big. Maybe like 500. And I hit graph again. Now, I really wish I could see closer in. Like my y's, I'm going up way higher than I need to on my y's too. So I'm going to go back to the window and say my y's don't need to be like 10,000. Maybe like 1,000. And I hit graph. Now it's coming in really good. Do you see I got a really obvious low spot now? I had to keep playing with my window until I can finally see the low spot. Now that's the low spot, that's the minimum. So would you, if you have kind of lost me there, would you go back and get your window set to be the same as mine? You'll be able to see it really nice. X min is 0, X max is 500. Get there on your window. You know what calculator is? Oh, I just couldn't see it behind the book. Sorry. Okay. And then at Y min 0 and Y max is 1,000. You can tell I just played around with it until I found numbers that where I could see that. And now that I've got it, hit graph, and then go to second, calculate, and we got to find the minimum, the low spot. It's number 3. And I got to go to the left of it, so I keep hitting arrow to the left until I finally get to the left of it. Your calculators are way faster than my computer. For some reason, my computer can't process this part very fast. Hit enter, get just to the right of it. Hit enter. Oh, stop that. Dang it. Again, I wish I had the calculator speed that you guys do. Because it... Bah. Okay, I'm just going to do the absolute smallest here. Go to the right. There. Gas, go right about there. Okay, you probably got that way faster than I did, but X is 67. In the context of our question, what is 67? The width, good. And our height was, or our Y, sorry, was 268. What's the Y? The perimeter. Okay, so our perimeter was the Y. So our perimeter looks like 268 feet. And so realistically, you know, you probably have to round that up to 270 or 280 because you're going to have real world issues of don't want to order not quite enough fence. That would be really bad. So you probably have to order like 280 feet of fence. And if your fence costs like, you know, 50 bucks a foot, that's going to be a lot of money. All right. Moral of the story. You need to draw a picture. Your picture will be a rectangle probably. You need to label your rectangle as best you can using formulas. Then you'll get this one formula. You'll graph the one formula. And when you graph it, if you zoom in on the wrong spot, if you just zoomed in like right here, you won't see the low spot. But if you zoom out far enough and you get your window right, it looks like this. You'll find the low spot, and that's the answer. Okay, that's an application type of problem. I don't want to do another one just like that because I think you'll slip into a coma. So I'm going to do one that's a little bit different. This one's about a pool. Would you please, right now, draw me a picture of just the top view looking down on a rectangular pool with a walkway around it. There are rules on pools. they have to have certain things, like in Minnesota, they have to have a fence that's at least 6 feet high around the pool. That's to keep out like neighbor kids and dogs and that kind of stuff. Had a neighbor in our neighborhood who has a pool, and they couldn't find their dog for a while. Guess where the dog was? Yeah, it was really sad. Anyway, and you don't, if it's your own dog, that's one thing, but if it was the neighbor's dog, it'd be kind of worse in a way, because then your pool killed their dog, and so, and it's even really, really worse if it's their toddler. So you need to have fences up around your pool to keep people from falling in it. You also have to have, there's rules about how, you know, like how deep the pool can be, how, whether it can have diving boards in certain situations or not, and so there's a lot of rules putting up a pool. So in this scenario, it's required to have a walk of uniform width, 2 feet, and I'm sure you can have it wider than 2 feet, but it has to be at least 2 feet around the pool. And besides, you've probably never seen a pool that doesn't have a walkway around it. It's like right to the, like there's dirt and then there's the pool. That's pretty unusual. Maybe it's just a homemade pool or something. So basically we know it goes 2 feet this way and 2 feet this way. Do you see how this is sort of setting up like one we had before? Where this is our width and this is our length, and then it's not just the length around the outside isn't just L anymore. What is it now? L plus, not 2, L plus 4. And our width here isn't just W, it's W plus 4. And if we really leave it as L and W, that's going to make it wrong too. We need to get it down to just one variable. And what variable usually is it? It says let X be the length of one side of the pool. So let's let that be the W. Change that to an X. And then the other side, this one has an area of 1,000 square feet. So can you just in your head tell me what this one has to be? If you can't, then you go off to the side and you say this. Area equals length times width. Area is 1,000 equals length times, and the width is going to be X. Now solve for L. Divide by X on both sides. L is equal to 1,000 over X. Okay? And I know some of you probably could have done that in your head. Now, express the area of the plot of land needed for the pool and surrounding sidewalk as a function of X. So my area used to be length times width. And I guess I could still say it is length times width. But now the length I should call length of the whole thing. Instead of length, I'm going to put what? 1,000 over X plus the length of the whole thing isn't just 1,000 over X plus 4. And the width is this way, isn't just X, what is it? X plus 4. Guess what would happen if I graphed that? It would have a low spot. That low spot in it, because it's going to be basically like a parabola, sort of. The least area, that would be the minimum area. In other words, if you really want to build this pool in your backyard, do you have enough space to do it? So you could figure out this little calculation. You'd type this puppy into your calculator. You'd make sure the window made sense. You can't have negative lengths of the sides. You can't have a negative area of the pool. And so you'll get your window dialed in, and it will look something like this. And then you'll have this low spot, and you'll find it, and that'll be your how wide the pool is versus the area. And the low spot means the lowest area, so the area is over here. And this is like the width. And you find this answer, and you've got your answer. Okay, so mainly, it's like, you know what? Honestly, this is just like what we did on the last test that was on word problems. It's the same deal. Draw a picture, get formulas, get the stuff from the formulas into the picture, and the stuff from the picture into the formulas. Get one big formula at the end, graph it. The only extra complication is the windows can be a bear. You got to get the right window, and then you'll be able to see it. Okay? All right. I know it's kind of hot in here. The window, the Univent thing stopped working again. The guy was just here to fix it, and it was working when he got here. Of course, that always happens. He walks away, thing stops working. Bah. Your homework, actually, that's not it. For my class, the homework, in case you're following along at home, is page 254, 35, 36, 38, 40. Those are all application problems. So there's only 4 of them, 4 application problems. And then these 45 to 50 are all like review questions. I think they're even multiple choice. Pretty easy. Okay, so that's homework for tonight. I wanted to get you started on the first one so that once you're started, it's so much easier. You're like halfway down if you're started. So would you find a book? If you haven't got your own book with you, borrow one of mine, leave a shoe, leave a cell phone, leave something for collateral. I'm going to start 35 with you right now. I'll pause for a second while you get those books out. Okay. Seems like most people have their book. This is again off of page 254. Number 35. Rectangles that have an area of 182. It's kind of annoying when they say consider all the rectangles with an area of 182, but it is true. You can draw rectangles that are long and skinny with an area of 182. You can draw them short and fat that have an area of 182, but the point is that the area is 182. So I'm going to draw my rectangle, and I'm going to say area is length times width, and the area is 182. You see how this is shaping up just like the other ones? And then they do say eventually let x be one of the sides. I recommend you that you let the length and the width be the x. That way we can kind of be consistent. And then the length. You can solve for length here. Get length alone. Length would be equal to what? 182 over w. And so now I can put that in right here. 182 over w. There, I got my picture. It's only got, wait a minute, not over w. I've changed w's to x's. Okay, there I got my picture. It's only got one letter in it. Catch up to me if you haven't already. Okay, now it says express the perimeter as a function of x. I strongly recommend you always start with the general perimeter formula. 2 lengths, 2 widths, and then substitute in what we're going to substitute in. Usually perimeter, the thing over here is a y, and then 2 times, what's the length here? 182 over x. And what's the width here? Width is really x. And now I've got a formula that's only got x's. That's what they wanted. And then the part B of it is to basically do your graph. You're going to have to fuss around with the window to make the window look right. If you type in exactly what you see here, it will work. If you want to multiply it out first and say it's 182 times 2, which would be, what, 364 over x, that would be a little shorter, but. And then you find the low spot, and then it'll be your minimum perimeter. All right. At least you're started.